Cool. Okay, well, if you're wondering why I have another wardrobe change. We both have another wardrobe change.
Except now you can't see it because of our up next. But we did have a wardrobe change. There we go. Thanks, Dave.
Yeah, so I was incredibly honored to have been asked to MC Civo Navigate twice and get to introduce amazing people like Solomon Hikes, who's a former KubeCrash alum as well. Steve Wozniak was on the stage. So if you haven't checked out Civo Navigate, I'm going to give our colleague Sophia a little shout out here. Sophia, who does so many things behind the scenes, also is very instrumental in putting on a really, really great conference. And it's a community conference. It's not a vendor, it's vendor managed, because I don't understand how they do it all themselves, but they do. But they are really good about taking CFPs, about taking community content, and so we really appreciate all the work they do there. And Civo is a company that really is very community first, very much contributing back to open source. They have 3 CNCF ambassadors. I feel like that's the most of any one company of CNCF ambassadors. So that really just shows you the commitment to the community, and we've been lucky enough to work with them through the Kube crashes over the years. And so now let's see, without further ado, we are going to bring in Kunal, one of the CNCF ambassadors that I was talking about. And Kunal, you're a Kube Crash newbie, I guess I should say. I know you've attended Kube Crash before, but your first time speaking, so it's always great to have new speakers. But I've seen you speak a bunch of times on other conferences that we've done. So I know you're not new to this. But
I'm really excited about this talk because it is whether you're going to build your own IDP or buy one. And I feel like that is, I'm summarizing it. I know you're going to go into details. I feel like that is a super important topic. So thank you so much for being here. I'll add your slides to the stage.
Yeah, thanks for having me. Very excited. But yeah, as you mentioned, Lisa, I haven't spoken before, but attended and always supportive of the event. I think it's really nice that we're doing virtual events still. Making it more inclusive. I think we used to do Kube Crash before KubeCon, if I'm not
We used to, yeah. This is the first time we did it afterwards, but I love that we're able to continue the conversation. And even like your slide title, this was something that came up in the panel before Abby spoke. And so it's great how all the slides are tied in. And yeah, we love that we're so international. We are broadcasting to, we have people attending from 6 different continents. I'll let you guess which 7th continent is not represented. And so this is a truly global event, and there's people all over the world. And thank you everybody for joining.
All right, with that, over to you, Kunal.
All right, cool. Guess that's it. Welcome everyone to Kube Crash. I'm very excited. My name is Kunal. I work as a DevRel manager at Civo, and like mentioned, I'm also a CNCF ambassador and do a lot of community stuff. The agenda for today is something around, I want to talk a bit more about the evolution of platform engineering and where we are right now. Its role in modern organizations. We're going to talk about internal developer platforms and SaaS solutions. And then we're going to talk about a decision-making framework to help you decide whether to go with something more in-house or just pay a subscription fee and use a SaaS platform. I might not be doing a demo in this one. This is also a slide from like a workshop I had, but I can show Q1st demo, but I don't think there would be time in this one, but you can check it out. It's an open source project that you can play around with. But I won't spend too much time on this slide. I don't want to talk into the technical definitions. I'm sure others have covered. But I'm going to throw a question out there. I'll throw the question later. But when we talk about platform engineering, imagine that you're building like a really cool Lego castle, right? And what do you need to do in order to build a Lego castle? You need Lego bricks. And if you are a fan of Legos like me, you may have seen that. You have a box of Legos and it is like very well organized, right? So platform engineering is like preparing that box of Lego bricks for you. And it makes sure that you have all the different types of bricks that you need, like your windows and your doors and your walls. It's all very organized and very easy to use. So you can focus on building your Lego castle without really worrying about making the bricks yourself. And this is what platform engineering is, in the world of computer programming. It's like preparing a box of tools and parts for programmers and giving them everything that they need to build their programs, like, storage space, your clusters, infrastructure, for example, security, any other special softwares. And now they have this box ready and organized. Programmers can create like cool apps and websites more quickly and not worry about YAML files, for example. But that brings me to another point. Like if we talk about platforms, this is a question for the audience. Some people might agree, some might not agree. Do you think, when we talk about platform engineering, do you think like a few years ago, do you think operating system also sort of like resonates with the same concept? Can you maybe find out areas in which these two things intersect in each other? Because that's a question I got at a conference, and the guy was like, what about operating systems? They have abstraction, provide resource management, they enable development and operations. So is it sort of like, is it platform engineering? Discuss in the chat, and then I'll look at the chat later on. But this is a definition that I really like, that platform engineering drives organizational sustainability by practicing, so 3 strengths to it: socio-technical principles that provide a community-driven support system for application developers using standardized shared platform architecture. So just a bit about the advantages. It saves time. People can create apps much faster because they don't have to build everything from scratch. The platform provides tools and services that helps make better and more reliable applications. And because of that, it reduces costs because it's cheaper, because you're just reusing the tools and infrastructure instead of making new ones every time. You can try out new things easily, leading to more creative and advanced applications. And as more people use the applications, that platform can adjust to extra demands smoothly. It also makes sure that your apps work well all the time, reducing crashes or problems. Includes strong security measures to prevent against leaks and hackers and security vulnerabilities. And over time, also improving and updating your application, making it much more simpler and faster. Let me talk quickly about the evolution and how we are here right now, and then tie it in together with IDPs and in-house like your SaaS solutions. So very, very beginning, I'm going to take an analogy that let's say you're trying to make cake. You're making cake, you're baking cake. So in the beginning, when everything was manual in the very early days, it's like before VMs and stuff. If you wanted to build an application, you set up your own servers, configure network, handle all the technical stuff and everything. So it's like you're baking a cake from scratch every time. That was the early days. Then what happened is, came the rise of cloud computing, brought convenience and scale. So imagine, instead of baking a cake from scratch, you can just order it via Uber Eats or a bakery online. And cloud computing lets developers use their servers and services over the internet without having to own them. So this made things a bit more easier. And about when you talk about building more complex applications, what came next? DevOps and automation. So this became quite a big deal. It's like having a kitchen robot that helps you bake by automating a lot of tasks. DevOps, it's like development and operations working side by side. And this approach used automation to make building and running applications much faster and reliable. Then came microservices and containers, which brought flexibility and isolation. So when we talk about the Lego example, instead of in our Lego structure, imagine every single part is a separate block that you can move around. So this made your apps more flexible and easier to manage because each part can be developed and operated and managed independently. After that, platform as a service, serverless, seeing growth of all these technologies. It's like, let's say you want to make a movie, but instead of worrying about the cameras and the sets, you just focused on directing and acting, and the PaaS or serverless, they take care of a lot of technical background tasks. So in terms of like developers, they can just focus on building their application. It's very important to understand, how it relates with DevOps when before we answer the question, which platform to pick. And at KubeCon, some people, I saw that on a banner, it said DevOps is dead, ? We all know it's clickbait. DevOps is not dead, but if you disagree, that's fine. Let me know in the comments, and I'm happy to explore more and understand. So definitely two strands to it. But I'm going to give my perspective. When we talk about DevOps, combining software development and IT operations, we all know that DevOps focuses on collaboration and your CI/CD and your automation. Just the whole aim is to streamline the software development and deployment process. Then Kunal, what is platform engineering? Well, it's you can say, an evolution on the principles behind DevOps. So it takes the automation and the efficiency goals of DevOps that I just spoke about a step further by building a more standardized and accessible platform for developers. What does that mean? So when we talk about what the focus is, like platform engineering, for example, it is about creating a solid foundation. This can be like your tools, your servers, your infrastructure, and your services for developers to use. DevOps, on the other hand, is more about the process. So how development and operations teams work together, automate workflows, and continuously improve their practices. So when we talk about the primary goal of DevOps, it is to shorten the software development lifecycle, increase deployment frequency, and create a more dependable release process in alignment with your business objectives. And the primary goal for platform engineering is to provide a robust, scalable, and efficient platform that enables developers to build and deploy applications more quickly. So it's like an evolutionary step, if you will. And a key goal when we talk about platform engineering is to create a self-service model where developers can easily access the tools and resources that they need without really waiting for operational teams. So this is an extension of the DevOps' aim to reduce silos between development and operations. And also, when we talk about platform engineering, it often emphasizes on building platforms that are scalable and standardized, which means that they can handle growth which are consistent for all the users. DevOps, now you may argue, it also focuses on scalability, but its approach, I would say, is more centered on the continuous delivery and the integration pipeline. And some people may see like, as I already mentioned, platform engineering, where it aligns in the whole timeline as an evolutionary step from DevOps. But as the whole cloud native landscape becomes more complex, the role of platform engineering grows in creating more coherent and comprehensive platforms that can support a wide range of development needs. So you want to use MySQL, you want to use some other tool or whatever. Developers don't have to worry, or Redis or something like that. So in an ideal world, it should be like I just take it and I just use it. I don't want to worry about the cluster and all these other things. Similarly, in DevOps, what is the main part in DevOps? Automation is key, right? So including such things like your code deployment, your testing, infrastructure provisioning, monitoring. The feedback loop keeps going and going and going. What sort of tools do you use? You use CI/CD. Tools might include like your CI/CD pipelines, your configuration management tools, your monitoring solutions, so on and so forth. This might be a little confusing because while in platform engineering, you're also utilizing automation, but the focus is on creating the platform itself. Bold marks, right? Creating the platform itself. Now, this might include internal developer tools, cloud infrastructure setup, your service meshes, API gateways, and this platform is designed to be self-service for developers. So you don't have to worry about the operations team. You can just take it and you can use it in an ideal world. And lastly, I would say that the target audience for DevOps, practices are generally adopted by both the development on the operations teams. But with platform engineering, the primarily targets developers because, as I mentioned already, providing them with a platform that simplifies and streamlines their workflows. And the platform team is responsible for the architecture of the platform, the efficiency and reliability. So it often requires less direct interaction between developers and operations. At Civo, we did a survey last year about this same thing. Starting from the DevOps adoption, around 85% of the organizations said that they have either partially or fully adopted a DevOps culture, emphasizing its continued relevance and growing influence in the industry, as you can see on the screen. And about platform engineering, around 40% of the people said that in the DevOps roles reported a moderate to high level of familiarity with platform engineering. So like, okay, they had a clue of what it's all about. And amongst the organization that had already adopted platform engineering, half of them reported improved standardization, and around 40% said that when they adopted it, they saw a faster product delivery. And around 65% of the respondents agreed or strongly agreed that platform engineering is the next evolution of DevOps as well. When we talk about challenging and implementing DevOps, and resistance to change and the lack of standardization was emerged as the top challenge for organizations implementing DevOps practices. And as I'll show in the future slides, this was also true for platform engineering, like trying to convince them to have this culture shift, because it's much more than tools. I'll share about that in the coming slides. And then some emerging trends, which were also highlighted in our surveys. Cool. Now, let's talk about internal developer portals or platforms. When we talk about in the context of platform engineering, it should be like a one-stop digital hub designed for your developers within your organization. Like think of it as like a private toolbox where all the tools and all the resources and all the guidelines and all the support that is needed for software development is all stored in one accessible place, typically including your libraries, your development tools, testing services, all sorts of things. Don't forget the documentation as well. And the goal is just to, as I mentioned again and again, to streamline this development process, reducing that the connection between the operations team. Like if you want to use something, you should just be able to do that via your platform, and just centralizing these resources that helps in maintaining a consistency, enhancing productivity, and supporting the overall SDLC or software development lifecycle within that organization. So if you're building, let's say, stuff on your own, there are multiple advantages to it. First one being pretty obvious one, because you're building on your own, which is customization. So you can tailor specifically to meet specific requirements and workflows based on your organization. You have full control over the security and compliance and the configuration of software and data. And it's also easier to integrate with your existing infrastructure, like your systems and your data sources, and also cost effective, for large scale, in the longer term, for large organizations that have many users. But because you're doing all of these things yourself, there are challenges as well. First one being obviously maintenance. So it requires internal resources for troubleshooting, updates, and maintenance. Initial setup cost, time, because you have to make initial investment for development and deployment. Some people might face scalability challenges, and you also rely heavily on your in-house IT team for ongoing support and development. So that's if you choose to do it on your own. SaaS solutions, on the other hand, it's easy to access and use. Just sign up, add your credit card. If you have an internet connection, you're good to go. Generally, have been user-friendly and accessible, lower initial costs with the subscription-based pricing models that many platforms offer. There are open source tools that you can try out, and that there are a lot of proprietary software as well to do it for you. No maintenance hassles, because they take care of the updates and security and maintenance, and also scalability and everything. You can scale up and down based on your infrastructure needs. Challenges involved less customization, options compared to in-house solutions. Subscription fees, can vary over time, especially with a large number of users. Sometimes, because also you're relying on a provider, so data security concerns. If you're storing like sensitive data on external servers and you're dependent on that internet and the vendor, and it's you have to put interest based on their like what's the reliability like and everything. In terms of like what to do, like decision making, how do we assess that, which one to pick? It all starts with accessing where you are right now, so your current state. So start by I'd say taking a really comprehensive inventory of your current DevOps practices and your culture and the tools you're using right now, and make a list what is working well and what needs improvement. And a critical aspect that I shared in the previous slides about our survey revealed that there was when we talk about lack of standardization when implementing DevOps practices. So consider how this might be factoring into influencing your operations, and then talk to yourself and think about, like, ask yourself the question, what do you hope to achieve with platform engineering? Do you want faster delivery times, improved standardization, increased efficiency? So have clear objectives that will guide you, your transition process, and also help you measure your progress as you move forward. Yeah, so define your goals. That was the next one. Also, then identify the necessary skills and tools that are relevant to your organization and how you would work with that. And it also starts with the culture. So platform engineering is as much about the culture as it about tools and technologies. So foster a platform mindset. What I mean by that is cultivate a culture that emphasizes on learning, collaboration, and transparency. And when we talk about transitioning, planning your transition, create a detailed roadmap for your transition. So this might involve phases like pilot projects, a broader implementation, and continual refinement. One question I get quite a lot is, when you're doing this transition, do you do everything at once, or do you do it step by step? Before I move on, I would like people to share in chat, like, would you attempt to change everything at once, or instead implement changes gradually and learn from every step? Okay, so implement gradually, because in our survey we found that the resistance to change was a significant challenge in implementing these practices, and a similar challenge can be expected here as well. Lastly, because you're doing this shift, so it's also important to measure success, so establish clear metrics for success. Now, this can be, I don't know, you let me know. What can be some clear metrics for success in the chat? Deployment frequency can be one, lead time for change, mean time to recovery, things like that. Lastly, I would like to share that it's the work is not done here, because it's a continual process, platform engineering. So learn from your experiences, refine and improve your practices and tools and culture. I also want to talk about what is next. So this is a sort of like how you decide, what to do. So if you want to I'll share the slides later, but yeah. What is next? This is a little meme, but I don't know how accurate this might be. Maybe you can correct me if I'm wrong, if we have to swap any of these two. But yeah, next step. What is the next step? What do you think the next step is? I'm going to check the chat real quick. Next step, next step, next step. Someone mentioned it in the chat when Lisa was speaking. What are you going to see in the next few years? I'm checking the chat. All right, no worries. I think abstraction maybe, because I'm seeing a lot of companies at KubeCon do that. Cloud providers did this for virtual machines. Kubernetes did this for containers, and platform is going to do this for services and applications. So I think a further drive for automation, making it more accessible for engineering teams. Some of the challenges that people can look out for include how do you make it secure, your SOC compliance for larger organizations, and if you're in a hybrid environment, then how do you balance complexity? So I think in the future, teams will become small, so do more with less kind of theme, So more automation, more building blocks are, I think, essential. And we can't ignore like AI and ML into platforms. So I think we're seeing integration of that as well. Going back to my example of the kitchen example, it's like having a smart assistant in your kitchen that learns from your favorite recipes and suggests new ones. So making the platforms smarter and able to adapt over time. That's a terrible analogy. I'm going to remove this from my slide. The kitchen one.
Yeah, Kyle, there was a few questions. The questions are coming up in the form of comments. So if any of those folks that are making comments actually have a question in there, maybe rephrase to ask the actual question. But I think a few things have come up. And maybe something you haven't addressed yet, which might be interesting, is how do you recommend the balance between or the trade-offs between customization and external dependencies when you're making these decisions?
Yeah, I think it depends on the specific needs and priorities of the organization. So as I mentioned, like when you talk about creating the roadmap, so evaluate the criticality of customization and security requirements and what sort of resources that you have available, and a long-term scalability. Just it's about finding the right balance. I'm going to answer it depends quite a lot. That might be annoying, but that's the honest truth. So evaluate how critical customization is for you, the security requirements, like literally list that down, the resource availability, and the fourth one, long-term scalability. And then using these four, strike the right balance. I can share some resources also.
Yeah, and can I just drill down on one of the things you just said, because security and compliance is something that kind of keeps coming up, and I think there was a really interesting point made earlier about platform engineering, like when to do it, like when would you, because everybody has platforms, but when do you go in and kind of like engineer or re-engineer? And really, we have our reasons we want to do it. We talk about features and ease of use and UX for developers and things like that. But really, compliance is a big reason, and security for why we have to do it, right? So you mentioned that, but can you mention some best practices?
Well, when we talk about security compliance, and when we talk about like the two options, develop like having something in-house or having a SaaS solution, just conduct a thorough security assessment for both the options. Some of the things that you should consider is, data privacy is one, and because you're working with developers, so access control, how you're managing that, encryption, compliance. And if you're going with a SaaS platform, then the vendor transparency, that's another one, and regulatory alignment. So I think conduct these assessments for like both, if you plan to do it on your own, or if you go with the SaaS platform, and then see what works for you. So these are some of the factors that you should look at: data privacy, access control, compliance, vendor transparency. Yeah.
Okay, that's awesome. And I don't know if Chris is still listening, but Chris, that's a question for you too. During your fireside chat, you could talk about how you've actually built that at NatWest, which I think would be interesting for folks. Okay, were there any other questions that came up before we still set some requirements? Or we got it.
Do I have time? I think I have some other few more slides.
Oh, you did? Oh, I'm so sorry. Okay, let's put a slide back up.
Yeah, let me do it.
Yeah, like a couple more minutes.
But no, these are just some resources that you can look into. This is a nice community for platform engineers. You can check it out. We did a webinar at Civo. You can check that out. Sorry for the plug, but I did a video as well on the Civo YouTube. You can check that out.
You can
There was
always.
also an now that I'm going to share other stuff as well. So there was also there was an interview with Zoe between Zoe and Carolina on the, I think it's the Level Up Engineering podcast. You can just Google that, you will find it. So this basically outlined the challenges and support surrounding platform engineering at HubSpot. So at HubSpot, they have adopted platform engineering, and they shared, a bit more about, what they did and how they're empowering their developers to focus on, more on writing code and less on managing the underlying like infrastructure and stuff, and how they communicate and everything. So this is a nice podcast. There was also another interview by Jean, who's the former CTO of Shopify and VP of Engineering at Atlassian. And they speak about their insights on the importance of investing in platform engineering. This was the engineering speaking is so hard. Engineering enablement podcast. You can see it on the screen. So I think if you Google this and Jean-Michel, I believe I pronounced that correctly, interview, you will find it. And one good point, like you were mentioning, where to allocate this. So in the interview, if you listen, he advocates for allocating 50% of the R&D resources to platform work. And he argued that it provides long-term business impact. And that's the former CTO of Shopify and VP of Engineering at Atlassian. So good, something to think about. But those are some like case studies I think you can look at how other companies did it. That's it. Yeah, I think, just about the transition, it may seem daunting, but significant, I think successful implementation can yield very nice results. But the key I would say is preparation is what I would summarize it with, and a step-by-step transition strategy. So that should be like the way to go. And think about what you need, why you need it, and and I hope the difference between platform and DevOps is also cleared. Platform engineering and DevOps. Thanks for having me.
Thank you.
I'll be in the chat as well.
Yeah, stick around in case there's any more questions for Kunal. Kunal can answer in the chat. And Kunal, thank you for being such a wonderful community member as well, and all you do for the Kubernetes community globally. Thank you so much for all of that.
Yeah, thanks for joining, everyone, and enjoy the amazing talks.
Awesome.
Yeah, thank